Hey there everyone, welcome to Chapter 7, Section 1, Exponential Growth and Decay. Right at the top, just want to go over, in essence, what exponential growth and decay means. And in simplest form, it's going to be written as, f of x or y equals b to the power of x. So b is going to stand for your base, all right, and x is going to stand for your exponent. So your base, if you're looking at it on the graph, I wrote when x equals 1 because you see how this picture is drawn? It says 1 comma b. Anything to the first power is itself. So if it's at 5 to the power of x and you were looking at the graph of 5 to the power of x, well, it's going to say 1 comma 5 here because 5 to the power of 1 is 5. That's what that means by base is when x equals 1. Okay? X is always the exponent for exponential functions. All right, it can't be an exponential function without x in the exponent. Otherwise, it's a polynomial function like a quadratic or a cubic or quartic, something like that. Okay, the main difference between exponential growth and decay is that if it's growing, it's going upwards from left to right, and if it's decaying, it's going downwards from left to right. Other than that, they have pretty much the same properties. The domain is all real numbers. You can move left and right freely, but the range, it's always going to be y is greater than 0 if it's in the form of b to the power of x. So that means you have an asymptote at y equals 0 or the x-axis, okay? So you're going to have an exponential growth function when b is greater than 1. I'm just talking about positive numbers here, so 1.1 to a billion, that's all greater than 0. Less than 1, but greater than 0. That's what I mean by I'm talking about positive numbers here. So 0.99, 0.16, 0.001, these are all exponential decay problems, okay? That being said, let's just label some. Label these as growth or decay. Well, if the base is bigger than 1, it's growth. So 2 is bigger than 1, and 5 over 4 is bigger than 1. You know fractions can be bigger than 1 if the numerator is greater than the denominator. Okay, so 1/2 and 0.4, those are going to be decay problems because they're both smaller than 1. All right, so in the next section, we're just going to evaluate and we're going to show our work. So we're going to do, it's so short, we're going to do two different problems. We're going to evaluate when x is -2 and when x is 3. Okay, so here I have 1.5, so I'm just going to do 1.5 to the power of -2. All right. Just type it into your calculator. I get 0.4 continued. All right, so I'll put the line on top. Then I'll do 1.5 to the power of 3. All right, I'm going to get 3.375. Okay, that's all there is to it. Moving on, I have 2 to the power of x, so 2 to the power of -2. Remember, negative exponents don't mean negative numbers. They mean fractions. So our answer is going to be a fraction, not a negative number. Well, actually, in this case, it is a negative number because 2 to the -2 is 1 over 4. So it's saying 1 over 4 minus 2, and that's going to be -7 over 4. So I got a little ahead of myself. But 2 to the power of 3 minus 2. 2 to the power of 3, that's 8. 8 minus 2 is 6. So there's that one. The last thing, 2 to the power of 3x minus 8. So I'm going to say 3 times -2 minus 8. All right, I'm going to plug that into my calculator. And that's going to give me 2 to the -14 power, just FYI. So you're going to get a fraction. This is a better example. So 3 times -2 is -6. And -6 minus 8 is -14, as I mentioned before. I'm just rewriting that 2 there. And so you're not going to get a negative number. I'm going to get 1 over 16,384. Okay? Negative exponents mean fractions. 2 to the 3 times 3 minus 8. That's 9. 9 minus 8 is 1. 2 to the first power is 2. Or type that all in at once. It'll tell you 2. But that's all there is to evaluating it, okay? The next thing I want to cover is the compound interest formula. So you see compound interest in any sort of financial account, whether it's a savings account, checking accounts even, certificate of deposits, bonds, stocks, mutual funds. Then you got, loans, car loan, house loan, personal loans, any sort of money, anything involved with money and interest is going to be compounded some way or another, okay? So this is the compound interest formula. What the A means is that's your end amount. That's what you're going to equal, all right? So P is your principal or your initial amount. R is going to be your interest rate, and you're going to express that as a decimal, meaning you're going to move it over 2 times to the left. And then T is going to be time in years. So if it says 5 years, T is 5. N is your number of compounds per year. So if it says it's compounded monthly, that's 12. If it says it's compounded quarterly, that's 4. Compounded every day, that's 365. If it says compounded weekly, that's 52. So I think you get the picture because there's 52 weeks in a year. So that being said, let's just do these 2 examples here. You deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. All right, so P is going to be your initial amount, so that's $9,000. And then the 1 plus, that's just from the formula, okay? You're going to move your interest 2 places over to the left, so that's just 0.0146. And then you're going to divide it by the number of compounding periods per year. And it said quarterly, so there's 4 quarters a year. All right, I can close the parentheses now, and I can raise it to the power of n times t. So there's 4 quarters in a year, and it said for 3 years. So you can raise it to the power of 12, or you can just type in 4 times 3 in the exponent, okay? The nice thing about the graphing calculator is that you can type this in as it appears, and it'll give you the final amount, all right? Before you type it in, though, you want to make sure your calculator is set so that it can handle more decimal places, because when we deal with dollar amounts, we need 2 decimal places, and the bigger the number, the less decimals the calculator is going to show you, okay? So what you want to make sure you know how to do is you want to make sure you know how to adjust the settings of the calculator. So if you're using the TI Inspire from, a blank calculator screen or from the Scratchpad even, you can press that dock button, and then you go to number 7, settings and status, and then you go to number 2, document settings, and the default is float 6, and you can change that to float 8. And that way you don't have to worry about the calculator giving you an already rounded amount, and it'll be rounding it to the nearest 10th place when we need to round to the nearest 100th place, okay? But going back to this, just typing this into the calculator, this is an investment, so I'm going to gain money here. The end amount is $9,402.21. All right. So if you take the difference of that, that's $402.21. That's money that you made just by keeping it in this account. Okay. So let's look at it from the other point of view, and that's a loan. You take out a loan on a car, that's $12,600. You're charging APR 3.99%. That calculate the actual cost of the car after 5 years when the interest is compounded daily. Okay, so we have $12,600 for our P. Then it's going to say parentheses 1 plus your R over N. Your R is moved over 2 times, so 3.99 is 0.0399. All right, and you're going to divide it by the number of compounding periods, so that's daily, 365 days, and you're going to raise it to the power of n times t. So I can just type in 365 times 5 for my exponent, all right? Type all that in. If you're in float 8, it'll give you the right answer. If you're in float 6, it'll round it a little bit differently. It's a small difference, but it's the principle of the matter. So you're going to get $15,381.81. So what that means is, let me write this comma a little bit better, is that you took out a loan for $12,600, and so the total realized cost of the car would be $15,381.81, meaning that's a difference of, almost $2,800. That's how much extra money you paid because you took out the loan. So, I guess the lesson to take out of this is whenever you have the opportunity, put down a bigger down payment so the loan amount is smaller, or see if you can pay off the loan early by making your monthly payments larger, things like that. Yeah, that's pretty much all I have to say about that. That's going to wrap up the notes, all right? So thanks for watching. Goodbye.